The next in our series of properties of exponents is power of a product. The learning objective for this lesson is to understand the product or the power of a product property. Pretty simple. Alright, so let's get started. So with a power to a product, I'm going to have a product of two numbers raised to a power. So how will this work? So we can use the order of operations to evaluate this expression. So if I take a look what's inside my parentheses, because that's my first part of PEMDAS, I have 4 times 5. So 4 times 5 gives me 20. Raised to the third still is outside. So this is the same as writing this as 20 times 20 times 20, which equals 8,000. We can also evaluate this expression by using 4 times 5 as a factor 3 times. So let's say I have 4 times 5 to the third. I could rewrite this as 4 times 5 times 4 times 5 times 4 times 5. Because I have my exponent of 3 and I have this factor 3 times. So I can regroup this. So if I take all of my 4's and I regroup my 4's together, I could have 4 times 4 times 4 times my 3 factors of 5, 5 times 5 times 5. And then if I wanted to simplify this, I can write this in exponential notation. So I can write this as 4 to the third times 5 to the third. 4 to the third equals 64, and 5 to the third equals 125, which also equals 8,000. We can use the same method to evaluate h times k to the fourth. So I could take h times k as a factor 4 times, because my exponent here is 4. And just like in the last problem, now I can regroup all my h's together and all of my k's together. So I have a total of 1, 2, 3, 4 h's. So I have h times h times h times h, all multiplied by 4 k's. So we got k times k times k times k. Sorry, that's a little messy. Right, now I can rewrite this in exponential notation. So I have h to the fourth times k to the fourth. So the definition of the power of a product, let's write this out. So to find the product of two algebraic expressions with the same exponent. This is the first time we've seen anything about this, what to do if we see the same exponent. But if we see the same exponent with a product, we are going to be able to multiply their bases. So how would this look? So if I had a raised to the m multiplied, because I'm talking about a product, so it's got to be multiplication, times a different base. So let's use b. Now it has to be the same exponent, so I have to reuse my m. And so to find the product of two algebraic expressions with the same exponent, which is what we have here, we are going to multiply the bases together and keep the same exponent. So that's what our power of a product tells us. Alright, before I conclude this though, we have to take a look at this. So earlier, we had been talking about the product of a power. Now in this latest one, we just took those two words, switched them around, and made it a power of a product. So what is the difference? So we just went over the power of a product. So the power of the product told me that if I have two different bases raised to the same exponent being multiplied together, then I'm going to multiply the bases together. Now what did my product of a power tell me? So before I had it so that if I was multiplying two numbers together, so let's say I have a again raised to my m, I have to have the same bases. So I have to have a as the base, and I can have two different m's so that I'm going to end up adding these two exponents together. So in my product of a power, I am multiplying two numbers that have the same base to a power. With my power of a product, I have a product, and now I am going to be looking at my power. So just make sure that you are paying attention to the wording of the property.